Matter and energy pre-assessment. Number 1. Which of these is not soluble in water? A. Oil. B. Salt. C. Honey. D. Sugar. Number 2. The table lists some properties of 4 different samples of matter. Sample, state of matter at room temperature, color, attracted to magnet, conducts electricity, solid, clear, no, no. Sample 2, solid, silver, yes, yes. Sample 3, liquid, clear, no, yes. Sample 4, liquid, white, no, yes. Which 2 samples could be glass and salt water? A. Samples 1 and 2. B. Samples 3 and 4. C. Samples 1 and 3. Or D. Samples 2 and 3. Number 3. A student puts 4 objects in a bucket filled with water. The objects are listed below: plastic ball, glass marble, metal paperclip, wood block. Which 2 objects are most likely less dense than the water? A. Wood block and metal paperclip. B. Plastic ball and glass marble. C. Metal paperclip and glass marble. D. Wood block and plastic ball. Number 4. A piece of copper is placed on a hot plate for 1 minute. When the copper is picked up with tweezers, the copper is as hot as the hot plate. The copper is said to be A. Heat non-conductor. B. Heat conductor. C. Electrical magnet. Or D. Insulator. Number 5. Students fill their cups with cold water from a drinking fountain on a warm day. Student A fills a plastic foam cup. Student B fills a paper cup. After 10 minutes, which cup of water will be colder? Explain your reasoning. Number 6. A student measures the mass of several substances and records the results in the table below. Substances for investigation. Substance, mass. Water, toothpicks, table salt, sugar cubes, alcohol, cooking oil, marbles, plastic cubes. What is the difference in grams between the total mass of the liquid substances and the total mass of the solid substances used in the investigation? Number 7. Alan read a riddle from the class chalkboard. The riddle is shown below. I am a colorless and odorless substance. I can change shape. I am not magnetic. What am I? Alan thought the answer to the riddle could be air or water. Name a property Alan should ask about to help solve the riddle. Explain how knowing this property will help solve the riddle. Number 8. Which container from the sheet on the front represents a gas? Jar 1, jar 2, or jar 3, or none of the containers represents a gas. You are using these containers down here. Number 9. Students made observations of several different substances and classified them into the groups shown above. Group 1, wood and iron. Group 2, water. Group 3, helium and nitrogen. Which materials could be classified into Group 2 in this chart, and why? Number 10. The diagram shows a solid changing into a gas. Why would a solid change into a gas? Number 11. A teacher asks 6 students to design and build solar ovens that could be used to boil water. After the ovens are complete, the students record the maximum temperatures that can be reached inside their ovens in 1 hour. Solar oven data. Oven number, maximum temperature reached, degrees Celsius. Which list identifies all the ovens that must be redesigned in order to reach temperatures that will boil water in 1 hour? And then here are your options. So F, ovens 1, 3, 4, 5, and 6. G, ovens 1, 3, 5, and 6. H, ovens 1, 3, and 6 only. Or J, ovens 1 and 3 only. Number 12. A student measures the temperature of water being heated on a hot plate. The student observes that the temperature of the water is 53 degrees Celsius. How many more degrees Celsius must the temperature rise before it reaches the boiling temperature of water? Number 13. Some students put 2 ice cubes on separate plates. One ice cube had a mass of 80 grams. The other had a mass of 40 grams. Which result would be the same for both ice cubes in this investigation? F, the time it took each ice cube to melt completely. G, the temperature at which each ice cube melted. H, the amount of liquid produced on each plate. J, the total volume of each ice cube. Number 14. Jody's parents are careful to separate their trash into recycle and non-recyclables. What is the best way to separate the recycled aluminum cans from the other cans? F, by weight. G, by comparing labels. H, by using a magnet. Or J, by hardness of the metals. Number 15. A student made a mixture using equal amounts of salt and pepper. The salt grains were the same size as the pepper grains. What should the student do to most easily separate the pepper from the salt? Write your answer below. Number 16. Some people add sugar to their hot tea. Which property of the sugar remains the same when the sugar is in the tea solution? The taste of the sugar, the size of the sugar crystals, the color of the sugar, or the texture of the sugar? Number 17. A mixture of beads was placed in a container, as shown below. The beads are of various sizes, and each one is made of plastic, glass, or steel. The mixture would be easy to separate because all the beads, A, are less dense than water, B, are solids, C, have the same mass, or D, are attracted to a magnet. Number 18. Some students added sugar to 3 cups of water. The water in each cup was a different temperature. They stirred each cup of water after adding the sugar. Their data is shown in the table. Amount of sugar by grams, water temperature, and the time it took to dissolve in seconds. Which of these best explains why the sugar dissolved at the rate it did? A, sugar dissolves faster in water that is warmer. B, sugar dissolves faster at room temperature. C, sugar dissolves faster in smaller amounts. Or D, sugar dissolves more quickly in water that is stirred. Number 19. A student adds 10 grams of 4 different powdered solids into 4 different beakers. The student then adds 100 milliliters of water to each beaker, stirs the mixtures, and allows them to sit for half an hour before recording observations. Which question is the student most likely trying to answer with this investigation? F, at what temperature do the substances dissolve? G, how much water is needed to cause a substance to change state? H, what causes a substance to sink when put in water? Or J, which substances dissolve in water? Number 20. A worker built a sidewalk and pressed some large salt particles into the concrete while it was still wet. When the concrete was dry, the worker washed the sidewalk with water. The picture below shows the sidewalk after it is washed. What most likely happened to the salt? F, it evaporated into a gas. G, it turned into concrete. H, it dissolved in the water. Or J, it turned into a solid. Number 21. A student combined powdered paint with water to make a small amount of a blue liquid paint mixture. The student left the paint mixture in an open container. Several days later, the student found the container and observed that changes had occurred. What most likely happened to the mixture? A, the container was empty after the mixture evaporated into the air. B, the paint evaporated, leaving only clear water in the container. C, the water evaporated, leaving only a dry blue solid in the container. Or D, the liquid paint mixture was lighter in color after some water evaporated.